Very important JE topic, which is Newton's sum or sum of higher powers of root. So here I'll start with a motivating example before we go in the physics of the maths of Newton's sum. And we'll also see the proof very soon. So let's start with the question. We have a quadratic expression x square plus x minus 1 equals 0, giving two roots alpha and beta. Let's define Sn as alpha power n plus beta ka power n. Preferably I am defining it right now particularly for positive integers, but we'll soon extend it for negative and fraction. One way is to directly compute the value. Sum of root is minus b by a. Sum of squares of root is a plus b whole square minus 2ab. So this quantity is 1. Alpha beta is c by a, which is minus 1. So that gives you 3. Similarly, we can find alpha cube plus beta cube with a plus b whole cube and so on. Alpha 4 plus beta 4 can be found with alpha square plus beta square, and this can be written as e plus b whole square minus 2ab. So once we know alpha square plus beta square from before, we can keep on getting the answers. But there is a very cool method of doing this. Okay, let's try to understand that. Since alpha is the root of this equation, so clearly alpha will satisfy this, right? So alpha square plus alpha minus 1 equals 0. It may be real or imaginary. So is the beta. So beta square is going to satisfy this. Now we can definitely add the equation. So by adding, we'll get very interesting result, which is S2. By definition, alpha square plus beta square, we can name it by a symbol S2. This guy S1 minus 2 equals 0. So we know, if we know S1, we can easily calculate S2 from here, right? Which is minus. So if we know S1, we can easily calculate S2, which is 2 minus S1. How to get S3? Now that's a challenging part. To get S3, basically we need to create alpha cube and beta cube kind of structure. So we know since alpha is the root of this equation, we can still multiply this equation with alpha, right? So alpha cube plus alpha square minus alpha is 0. If alpha satisfies this, alpha must satisfy this, right? Similarly, beta will also satisfy this. So beta cube plus beta square minus beta equals 0. What I did is just multiplied the second equation with beta. Now when I'm doing so, we are getting extraneous root, right? Because this equation x square plus x minus 1 is satisfied with alpha and beta. Right now I multiplied with x and then kept x equals alpha and beta. So by doing so, I have forced one extraneous root called x equals 0. So keeping in mind like neither of alpha and beta is 0, we can tell still I can add this equation. So that will give S3 plus S2 minus S1 is 0. Now that's a good news, because we can calculate S3 again based on the previous two number, S1 minus S2. Similarly, if you multiply now this cubic expression with again alpha, we'll get alpha 4 plus alpha cube minus alpha square equals 0, beta 4 plus beta cube minus beta square equals 0. We simply add this equation, which gives S4 plus S3 minus S2 equals 0. So there is a recursion which gives me the value of all next number based on the previous number. In general, if you multiply with alpha to the power n, in the original equation, we'll get alpha to the power n plus alpha to the power n minus 2 plus alpha to the power n minus 1 minus alpha to the power n minus 2 equals 0. And so is beta ka power n minus 1 minus beta ka power n minus 2 is 0. If we'll add this, we have a recurrence Sn plus Sn minus 1 equals Sn minus 2. And that's really cool, because with this recurrence, it's true definitely for all n. And here we are making it positive integers. In fact, this can be extended even for negative integers. How? Because in the expression x square plus x minus 1 equals 0. Let's say if I divide it by x ka power n plus 2. So we have x to the power 2 by x ka power n plus 2 plus x by x ka power n plus 2 minus 1 by x to the power n plus 2 equals 0. So now we got 1 by x ka power n plus 1 by x ka power n plus 1 minus 1 by x ka power n plus 2 equals 0. So this I can write as s to the power minus n plus s to the power minus n plus 1 equals s to the power minus n plus 2. Clearly this is allowed because x is not 0, right? So even when n is here positive integers, still we can tell like 1 by s5 plus 1 by s6 is gonna be 1 by s7. So on and so forth. So we know like we can always get the next generation from previous generation, right? And that easily gives you the value of s7 now, because we can just start plugging the value in this recursion, and which clearly tells s1 is sum of root, so which is minus b by a, it's minus 1. Once you know s1, I can just plug here, which will give me s2. Okay, so s2 will become 3, which I have found otherwise as well. Similarly, we'll get s3, so s2 is 3, s1 is already minus 1, so we are getting s3 as minus 4. Again, s2 is 3, s3 is minus 4, so that will become plus 4, so s4 is 7. What about s5? It's going to s3 minus s4. 20 plus s19 by s18. From the recursion we have already seen, if I'll put n values at 20, so s20 plus s19 is going to be s18, and clearly s18 is non-zero, so this value is going to be 1. The next question, we have sk plus sk minus 1. So from recursion, again sk plus sk minus 1 is always sk minus 2, as I have proved. So this quantity is 0, hence this sum is 0 plus 0 plus 0 and so on. So answer is 0 for the third. So this was the very simplest application of and motivation for Newton's sum, where if alpha and beta is given, we can find clearly higher powers of root. Okay, so before we go further, let's understand what does Newton's sum look like for a cubic expression. So a general cubic expression will be in this fashion: a2x plus a3 equals 0. Let's define Sn equals alpha to the power n, beta to the power n plus gamma to the power n, where alpha, beta, gamma are the roots of this equation. It may be real or complex. Okay, so the Newton's sum is as follows. It relates the coefficients with powers of root. So I start with a0 s1 plus a1 equals 0, which is obvious because sum of root, you know, alpha plus beta plus gamma, s1 will be minus b by a, minus a1 by. Clearly a0 is not 0 because we are having cubic expression. What is now non-intuitive and which I am going to prove is it holds true for even s2. So a0 s2 plus a1 s1 plus 2a2 is 0, the second statement. Even we can get for s3, a0 s3 plus a1 s2 plus a2 s1 plus 3 a3 equals 0. Right? Then we'll have a0 s4 plus okay, so a0 s3 plus a1 s2 plus a2 s1 plus 3 a3 equals 0. Now from here onwards, the pattern will change. Why? Because once we know alpha, beta, gamma is the roots of this equation, for 4 power we have to just multiply this expression with x, and then alpha, beta, gamma will satisfy. So from 4th power we'll have a0 s4 plus a1 s3. As you can clearly see, multiply with x and put alpha, beta, gamma and add the way I have added in the quadratic expression. This s2, a2 s2 plus a3 s1 equals 0. This is for 4th. For 5th one, we'll have a0 s5 plus a1 s4 plus a2 s3 plus a3 s2 equals 0. In fact, for nth power, from now onwards, we'll have a0 sn, a1 sn minus 1 plus a2 sn minus 2 plus a3 sn minus 3 equals 0. And this is valid for any n, greater than 3, or I can tell n greater than equal to 4. Now for n less than 3, like between 1 to 3, we have this expressions. So let's try to prove this. Of course, the first is self-proven. In the third still you can prove in a easier way. How? Because this expression is satisfied with alpha, beta, gamma. So clearly alpha will satisfy. So a naught alpha cube plus a1 alpha square plus a2 alpha plus a3 equals 0. And so is beta. So since alpha, beta, gamma satisfies this, so clearly these three equations will satisfy. Now once you'll add, it will be a naught s3 plus a1 s2 plus a2 s1 plus 3a3 equals 0. But still in a very nicer way, we have not proved how to get the second expression. One way is directly you can find alpha square plus beta square plus gamma square and try to relate this. But that will not be, like a very elegant proof for n degree expression. So what this Newton's sum is telling, like even this is true for n degree expression. What I mean, let's say we have a general polynomial a naught x to the power n, a1 x to n minus 1 and so on till an equals 0. And we define Sn as alpha 1 to the power n plus alpha 2 to the power n till alpha n to the power n. By fundamental theorem of algebra, any n degree equation will have exactly n roots, maybe real or imaginary or combination. Okay, so according to Newton's sum, we'll have again a naught s1 plus a1 equals 0. The second relation is a naught s2 plus a1 s1 plus 2a2 equals 0. So it's invariant, right? Third is a naught s3 plus a1 s2. So the index of a is increasing and index of s is decreasing. e2 s1 plus 3 e3 equals 0, right? Then we have a naught s4 plus a1 s3 plus e2 s2 plus 4 plus e3 s1 plus 4 a4 equals 0 and so on so forth. So this pattern will hold till n, right? So a naught sn plus a1 sn minus 1 and so on so forth. Okay, so we are starting for 4, we win with 4. We are starting with n, we'll get n a n equals 0. Clear? After this, we'll have a new pattern. So this is the generation for the index r less than equal to n, right? Now when r is more than equals n, the usual roots will satisfy the equation and we'll have a naught sn plus a1 sn minus 1 plus the last term, an plus an n times, so nan equals 0, which is basically given. So this you can easily find by alpha 1, alpha 2, alpha 3, alpha 4 and alpha n will satisfy this equation. From next inverse, now you multiply this with x, so you'll get a naught sn plus 1 plus a1 sn, so on so forth. The last will be s1 equals 0. And again we can multiply this further with x, this expression, and add all the roots, so we'll get a naught sn plus 2, 1 sn plus 1 till s2 equals 0 and so on so forth. So you can mimic the same idea as we are mimicking for quadratic expression. Okay, so let's try to prove this expression. What I'll do is I'll try to prove for a cubic, and exactly the same physics and philosophy we can extend for n degree expression. What I'll do is I'll prove it for a cubic expression by taking a specific example, so that completely you understand the physics behind this maths, and then we can easily extend it for generalized polynomial. So let's say we have a cubic. Specifically, I've taken this example, x cube plus 3x square minus 24x plus 1. Let's say it has got roots alpha, beta, gamma. So it has 3 roots. So clearly this cubic expression can be written in terms of factors, x minus alpha, x minus beta, x minus gamma. Because if I put alpha, it dies. So x minus alpha must be present, so that alpha minus alpha becomes 0. Similarly, if I put beta, it dies. So we must sense x minus beta kind of a stuff as a factor. And same goes with gamma. The leading coefficient is 1. We have 1x cube. So hence there is coefficient of these factors is just 2. Now we define all of a sudden psi t as 1 minus alpha t. So what's the motivation behind this definition? Let's define 1 minus alpha t, 1 minus beta t, 1 minus gamma t as some new function psi t. This is a nice thing because it will help us to calculate, let's say psi 1 is nothing but 1 minus alpha, 1 minus beta, 1 minus gamma. So if I ask you to calculate the value of 1 minus alpha, 1 minus beta, 1 minus gamma, just it amounts to psi 1. So somehow if I can relate psi 1 with f1 or f2 or whatever, I'll be able to, like calculate this value without basically multiplying and finding sum of root taken 2 at a time or alpha, beta, gamma, because the other way is just to multiply and get that. If I ask what is psi of minus 1, so it will just automatically calculate 1 plus alpha, 1 plus beta plus 1 plus gamma without multiplying them individually. So clearly we can see if I define psi t like this, so motivation is so that x minus alpha, x minus beta, x minus gamma kind of behavior is captured. So psi t can be written as after taking t common t cube into this, and this quantity is nothing but f of 1 by t. Now what we'll do, we'll try to like differentiate this expression. You'll understand why we are doing so, because it gives invitation to GP, and GP will give invitation to alpha, alpha square, alpha cube, alpha 4, so powers of root will appear. So obvious way of differentiating is logarithmic differentiation because things are in product. So let's take log. Ln psi is ln 1 minus alpha t in this. If I differentiate, so ln of something is 1 by something, and differentiation of psi t goes to psi dash t, as you can see. And this differentiation minus alpha by 1 minus alpha t, minus beta by 1 minus beta t, and minus gamma by 1 minus gamma t. Now here is a very nice game that we'll be playing with. I'm free to select t whatever I wish, right? Because I've defined psi t as this valid for psi 10, psi 100, psi 1 by 10, psi 10 to the power minus 10 or whatever. Intentionally and smartly I'm selecting t as small as we want. So why I'm doing so? Because if I select t as small as I want, say if 2 is too less, then definitely 1 by 1 minus alpha t. Okay, so this quantity magnitude I can always make lesser than 1 by selecting. You give me any value of alpha. Let's say alpha is, let's suppose 100. So I'll select 10 as 10 to the power minus 5. So that will automatically makes alpha t less than 1. The advantage that I'm getting is this series can be written as sum of GP. So it's 1 plus alpha t whole square and so on and so forth. Okay, so if mod of alpha t is less than 1, then we can clearly like push forward this term 1 by 1 minus something as 1 plus something is, and that's good news because that will give me sum of powers of alpha. Okay, because if alpha is 100 and let's say t I kept just 10 or t I kept 1, then it's divergence region. No more I'll be allowed to use the AP. So cosmetically I want to use AP. That's why I can always make t as small as possible, at least to bring the other physics out of the container, right? So with this motivation, psi dash by psi is minus alpha by 1 minus alpha t, because this quantity is too small, making it definitely smaller than 1. So mod can simply be taken out. And just with GP sum, it's 1 by 1 minus alpha t is 1 minus alpha t. This is same as alpha t plus alpha t square and so on and so forth. That's written over here. If you collect all this term, so we can clearly see we have alpha plus beta plus gamma kind of thing. Alpha square, beta square, gamma square, alpha cube, beta cube plus gamma cube. And in LHS, psi dash by psi. So psi is already known, t cube f1 by t. So psi dash will be this expression. You can just pause the video and check. So psi dash t by psi t comes to be simply f dash 1 by t, negative of that by t square f of 1 by t plus 3. Now from the RHS, alpha is hitting this, alpha is hitting alpha square or alpha cube and so on and so forth. So we attempted to define terms like alpha plus beta plus gamma, alpha square plus beta square plus gamma square. Just to make things more crisp and short-handed, let's define sk as alpha k plus beta k plus gamma k. Putting all these equations together, the RHS can simply be written as, because we can see from here, it's minus alpha minus beta minus gamma, minus alpha square minus beta square gamma minus gamma square and so on and so forth. So RS boils down to, hence RHS boils down to S1, T, S2, T square, S3 and so on and so forth. Now just plug all these values of psi dash by psi t in terms of f, and we got this expression at last. F dash 1 by t is f of 1 by t times 3t plus t square s1 t cube s2 and so on and so forth. Now f of t is already known to us because function is given. So f of 1 by t, or we can simply put, instead of x, put 1 by t. And we can differentiate that function, and we'll put 1 by t, so f dash 1 by t is known. By plugging all this, we got finally this expression. Now this is true for all t that I have chosen. So even if I select t equals 10 to the power minus 9 or 10 to the power minus 10, remember I am free to select very small t, 10 to the power minus 100, 10 to the power minus 1000. This selection is also impacted by alpha, but we are assuming alpha, beta, gamma is in quite control, like it's not too high, right? So since it's true for any choice of t, arbitrary choice of t as small as we want, so this must be an identity, right? So LHS must be equal to RHS for all value of t. And that's the good news, because now I can just compare coefficients of t, t square, t cube on both sides. So if you compare coefficient of t here, you see 3 t will get cancelled, so we'll get nothing. What we are getting is t 3 equals 3. So maths is like, I'm okay. Even I am okay because I have not done any mistake. So there is no inconsistency in coefficient of t. What about coefficient of t square? Now surprisingly, you see that gives you 6 equals 3 into 3 plus s1. So sum of root is directly got from there. If we'll compare t square coefficient, we are getting the second equation. Compare t cube coefficient, you'll get the third expression. So that is the relation between s2 and s1. Compare next coefficient, you'll get s3 plus 3s2 minus 24s1 plus 3. Okay, so we have one part of, like Newton's sum layer, which gives you the third generation, second generation, and first generation. For higher generation, still you can compare from this, as I have compared t cube, t4, t5, and so on. And now you'll see a different pattern for next generation. So it will be 4, 3, 2, 1, or 5, 4, 3, 2, which was evident by putting alpha, beta, gamma, by adding it. So you see the purpose of not giving you the extensive proof first for the n degree polynomial is somewhere your feeling of the proof will go down. So particularly for this cubic equation, I have solved this problem in another way. So a bit calculus, bit comparison, bit logic is used, and we got a wow feeling from here. Okay, so we are able to capture the relation between the powers of roots before degree 3 and after degree 3. The game before degree 3 was something else, and the game after degree 3 is quite simple. Okay, so to put it nicely in the fashion of Newton's sum, this was our generalized formula. So now you can clearly define again psi t as like 1 minus alpha t, 1 minus alpha 2t, clearly till 1 minus alpha nt, and you can repeat the same thing. The physics is definitely not going to change, and by comparison with the coefficient of t, we are going to get this n degree expression. So I hope you have understood and enjoyed the method of proof. Of course, to conclude the topic, it's definitely justified to take one example, so as to understand how to apply this for problem solving. So here we go. Okay, so here we go. We have three numbers, a plus b plus c, which adds to 0. So we have to prove that if a plus b plus c is 0, a cube plus b cube plus c cube by 3 into a square plus b square plus c square by 2 equals sigma a 5 by 5. So it is a very interesting question. Let's see how we can apply the Newton's sum here. Of course, the method 1 of doing so will be, you can put c in terms of a and b, and then start evaluating LHS. Put there in RHS and do a lot of traumatic job, and finally you can show LHS is going to be RHS from a class 10 perspective. The other way will be probably we can use a cube plus b cube plus c cube minus 3abc to calculate this value. This value can also be calculated, so we know the value of LHS and just equate with the value of RHS. But here we are going to use what we have done right now. Now clearly from the very statement of problem, you can see if I define Sn as a ka power n plus b ka power n plus c ka power n. Then the question boils down to S1 equals 0 and we need to prove S3 by 3 into S2 by 2 equals S5 by 4. So this is what we have to prove. Now S1 equal to 0 reminds us of a cubic expression because it feels like there is a cubic expression whose roots are ABC such that the sum of root is 0. So let's start with the general cubic expression. Let's say px cube plus qx square plus rx plus s equals 0. So for this cubic expression, clearly, let's say if ABC is the root of this equation, then according to the question, a plus b plus c must be 0. Now, is it possible to always form a cubic with ABC as a root? Of course, yes. So maybe P, Q, R, S might not be real. So you give me, let's say one number is I, other is 2, other is 4. And still this will become a cubic, right? So I can always write expression in terms of, like real or complex coefficient, whatever, that doesn't matter. But we can always generate a cubic expression having roots, these three numbers, given any number in the world. So now this automatically sum of roots equal to 0 tells you minus b by a equals 0, which gives q equals 0. So there is no coefficient of x square here. So now my question reduced down to px cube plus rs plus s equals 0. And now the updated problem statement is if ABC are the roots of equation, you prove that S3 by 3 into S2 by 2 equals S5 by 5. Now we know using recursion, we can easily find S3, S2 and S5. So let's start the game. A0 S1. Since we know A0 S1 plus A1 equals 0. So that would automatically giving A1 equals 0 because S1 equal to 0 in this case. A1 means coefficient of x square is missing here. So let me write A0 is P over here, A1 is 0, A2 according to our notation is R, and A3 is S. So with this notation we can keep on playing. Next is A0 S2 plus A1 S1 plus 2A2 equals 0. Right? The third expression will get A0 S3 plus A1 S2 plus A2 S1 plus 3A3 equals 0. Then we have A0 S4 because now from now onwards after degree 3 I can just multiply this with x and we can add all the roots. And then again multiply with x square, add all the roots, x2 add all the roots. So A0 S4 plus A1. Okay, so that we can do in a cool way now because like till 3 we have to use this basically Newton's sum. After that the Newton's sum is very obvious. So let's calculate. A1 is 0, so this term is gone. So A0 value is P, so PS2 plus 2R equals 0, so that gives me value of S2 as minus 2R by P. We'll put the value again here. A1 is 0, A0 is P, so PS3 plus A2. Sum of root is gone, so it's gone. So plus 3 times S equals 0. So that gives S3 equals minus 3S by P. So S2 and S3 is known. Now just we need to find S5. So how to find S5? We'll multiply this with x square. And directly we'll put the root alpha, beta, gamma and add the equation, right? So it will be px5 means p alpha 5 plus r alpha cube plus s alpha square equals 0. Similarly, we'll have beta will satisfy this equation. So is gamma. Just add this. So we have PS5 plus RS3 plus SS2 equals 0. So we know all these values. So PS5 equals minus R S3 minus S S2. S3 is minus 3S by P minus S into S2 is minus 2R by P. That gives the value of 3 RS by P plus 2 RS by P equals to 5 RS by P. Okay, so finally what we are having is S5 by 5 is nothing but RS by PS square. Let's calculate what is S2 by 2. So S2 by 2 from this expression, S2 by 2 is minus R by P, S3 by 3 is minus S by P. So if I'll multiply this, it will be RS by PS square. So S2 by 2 into S3 by 3 is minus R by P into minus S by P, so that's going to be RS by PS square. And very interestingly, you can see like these two quantities are equal. Hence, we have proven it. Okay, so you see like how in a very small, in a fantastic way, we are able to tackle this problem, which fills in the first go has nothing to do with the cubic expression, and then we executed this. Okay, thank you. Have a good day and try to apply this problem for all the JEE problems.